Professor Po-Shen Loh recently presented a new method for solving quadratic equations. In a previous video, we looked at a few examples of how easy it is to apply this method in a variety of situations. The link to that video is in the top right and in the description below. Note that when you combine all these steps, you inevitably still arrive at a special version of the well-known formula. When two methods each provides a solution to a problem, they have to be mathematically equivalent, even if they approach the problem from different directions. But what makes this new method so much easier to implement, or at least makes it feel like you're doing something different than the complex formula? Let's investigate. We consider the standard quadratic equation with a coefficient of x squared forced to 1 by dividing by it. You could now apply the well-known formula with a equals 1 to find the answer. An alternative method that is generally used is to try and find two numbers for which the product equals c, and then testing whether their sum equals minus b. If not, we try two different numbers. In this example, we see that 4 times 2 equals 8, which is c, and 4 plus 2 equals 6, which is minus b. Wouldn't it be nice if we could remove the guesswork? You could then have an easy fixed algorithm to apply. The big breakthrough here is that we swap the order of calculations around, and a little fragment of detail that has been known for thousands of years allow us to do this. We now start at the sum of the numbers rather than their product. We know that the average of two numbers can be obtained by adding them up and dividing by 2. The average of 4 and 2 is 4 plus 2 divided by 2 equals 3. In the quadratic equation, this equals minus b over 2, where the total equaled minus b. We therefore simply take the sum of the two numbers and divide by 2. Visually, this provides us with a point exactly halfway between the two numbers. But there are many other ways of also getting to that average. Any two numbers where the one is as far to the right of the average as the other one is to the left of the average will lead to that average. How do we know how far right and left to go? Let's indicate that distance by w. The one number would therefore be the average plus w and the other the average minus w. If we add them up, we get the required minus b. But how do we know which of the infinite number of values to use? It seems as if we're just at a point where we have to guess again, this time how much to move left and right, and then test whether the product of the two numbers equals c. But we can get rid of the guessing in a simple way. We now get to the product of the numbers. If we multiply out the brackets, it neatly becomes minus b over 2 squared minus w squared. The interaction terms cancel out since one bracket has a plus and the other a minus. If we now want to solve for w, we see that it simply becomes the square root of minus b over 2 squared minus c. In our example, c equals 8 and b equals minus 6, so the average would be minus b over 2 equals 6 over 2 equals 3. The expression now becomes w equals square root of 9 minus 8, or the square root of 1, which is 1. We now know that we need to add 1 and subtract 1 from the average to get to the two numbers. This gives us 3 plus 1 equals 4 and 3 minus 1 equals 2, which are the answers we obtained with the other methods. We therefore do not have to guess w, but can use the fact that their product should equal c to find an easy formula for w. When we combine all of these steps, you'll see that we've actually just derived a version of the well-known formula for the roots of a quadratic equation from first principles. But instead of starting at the end point of the formula, we started at the origin of what we're trying to solve, and went logically through the steps required. So, if you're struggling to remember or understand the formula, you can replace it with this method, which we can summarize as follows. Add the square roots of the square of the average minus the product to the average. Or in terms of formulas, add the square root of minus b over 2 squared minus c to minus b over 2. Let's quickly look at a few more examples. Here, b equals minus 20 and c equals 64. The average is therefore minus b over 2 equals 10, the square of which is 100. We subtract c to get 36, the square roots of which are plus and minus 6. Add these to the average and we have the two roots x equals 16 or x equals 4. And the method works just as well for complex numbers. You now take the square root of a negative number, which simply adds a complex number to the roots, but the idea remains exactly the same. I will now conclude, since I'm sure you can't wait to go solve a few quadratic equations. Enjoy!